Student friends, in yesterday's lecture we studied UZD with its construction, working, circuit symbol and its equivalent circuit, along with the meaning of intrinsic standoff ratio. Friends, this will be the last lecture from your syllabus, in which we are going to study IV characteristics of UZD. And as all of us are aware from the yesterday's lecture that UZD is a unijunction transistor which is composed of N type of semiconductor bar with P type of semiconducting layer diffused at the center known as emitter, ohmic contact at the bottom, ohmic contact at the top known as respectively B1 and B2. Thus we can say it has three terminals, emitter, B1 and B2. Friends, let us study today the IV characteristics of UZD. If we plot the graph of emitter current I versus emitter voltage VE of the UZD by connecting VBB as a fixed voltage and VEE between emitter and B1 as a variable voltage. Measure the emitter voltage and emitter current. Plot the graph of emitter current versus emitter voltage of the UZD. The resulting curve is represented here. So this is the IV characteristics of UZD. In this particular graph, emitter voltage is taken on y-axis, whereas emitter current is taken on x-axis. And then the graph is plotted. The graph is as represented here. So this is the nature of the graph of IV characteristics of UZD. Dear students, what we can conclude from this particular graph? From this particular graph we can conclude that at the beginning, when supply voltage VE is a negative, not necessarily it should be make negative, but here we are considered it. The minority charge carriers will conduct the current, that is represented here by IEO. It is called as a reverse saturation current. And as we go on increasing VE from minus towards the 0, from the graph we can say emitter current increases. Look at here. When emitter voltage becomes equal to 0, it crosses the y-axis. And if you further increase the emitter voltage, current still increases and becomes maximum. For a particular voltage, that current seems to be a maximum. The point at which current is maximum, that point we can call it as it is a peak point. And the voltage at this particular peak point, it is represented as a Vp. And that Vp is given by Vd plus eta times VBB, where Vd is the voltage across the PN junction diode. which is a part of UZT. So for silicon it is 0.6 volt, for germanium it is a 0.2 volt plus eta times VBB. So that voltage we can call it as it is the peak voltage which is existing at the peak point where the emitter current is maximum. After the peak point, what you observe from the curve that even though current is increased, voltage goes on decreases. After a peak point, UZT starts conducting, no doubt about that, so that emitter current increases, whereas emitter voltage goes on decreases. So this is the particular part within which there is an increase in current, but there is a decrease in voltage. This is against the Ohm's law. Because as far as Ohm's law is being considered, voltage is directly proportional to current. If you increase the voltage, the current is going to increase. But in this particular case, as voltage decreases, current increases, which is opposite to the Ohm's law. In Ohm's law, as voltage is proportional to the current, there exists a proportionality constant that we can call it as it is a resistance, whose value is positive. But in this case, decrease in voltage increases the current, means the resistance associated is negative. So that's why this region we can call it as it is negative resistance region of working of UZT. This negative resistance region continues till the valley point is reached, meaning thereby at the valley point voltage is minimum, and current is maximum. After this valley point, again if you increase the current, voltage goes on increases. This is called as a valley point because the shape is just like a valley where UZT goes to saturation. Friends, we can say working of UZT changes from cutoff region to negative resistance region. In between that, it is going to reach a peak point. From negative resistance region, it changes to saturation region after passing to the valley point. This IV characteristics of UZT explains the exact working of the unijunction transistor. Friends, this is how we can plot the IV characteristics of UZT, and by using that one can explain the working of UZT. So that working of UZT changes from cutoff region to negative resistance region, and finally it goes to saturation. This is what you have to remember as a IV characteristics of UZT. Very important aspect is it has a negative resistance region. It has to conduct the current maximum when voltage across junction equal to Vp, and that's eta times VBB plus Vd, where eta is Rb1 upon Rb1 plus Rb2. These are to be remembered by you, maybe going to ask in objective type of questions. What is the peculiarity of UZT now? UZT has a peculiarity, and that is it has a negative resistance region. That is its peculiarity. Due to this particular negative resistance region, it is capable to use along with some resistance and capacitor so as to design an oscillatory circuit. That oscillatory circuit, we can call it as it is a relaxation oscillator. A relaxation oscillator means it generates the waveforms like sawtooth waves, or it is apart from the sine waves, other than sine waves. Especially in this case, it generates the sawtooth waves or sweep waves. So that oscillator we can call it as a relaxation oscillator, which can be constructed by using UZT. This UZT is used in time-based circuit of CRO and television to scan the picture information on a screen from left to right horizontally. So that is so as to generate the picture faster on CRO, on TV, on computer screen, etc. To generate a picture raster or to scan the picture information horizontally from left to right, it is used as a relaxation oscillator in CRO, in TV, and also on the computer screen. It is there. Friends, it is peculiarly used as a sawtooth oscillator. You might be seeing sawtooth. Saw Marathi bussa म्हणतात tooth, tooth, a device that creates the saw from the wood. The shape of waveform generated is like a sawtooth. करवत ज्याला आपण म्हणतोय, करवतीच्या दाताचा आकार ज्या वेव्हफॉर्मला असतो त्याला सॉटूथ वेव्स, सॉटूथ असं म्हणतात. आणि अशा वेव्हफॉर्म तयार करण्यासाठी या युझिटीचा वापर केला जातो किंवा इट इज ऑल्सो कॉल्ड एज अ स्वीप जनरेटर. So these are the peculiar applications of the UZT. Friends, that's all about IV characteristics of UZT, its specification and its applications. These are the areas where the UZT can be used. Dear students, that's all about the last semiconducting device which is expected to be studied in topic number 5 and also in paper number 3, namely semiconducting devices. Friends, almost all we have completed 5 topics from your syllabus related to paper number 3, namely semiconductor, p-n junction diode, BZT, FET, and power devices, or to which we call it as a Thyristor. These are the 5 topics which are expected to be covered. Dear students, I hope you are regularly watching the video lectures. Due to this COVID-19 problem, face-to-face teaching become difficult. So that's why we adapted to teach through video lectures. If you regularly watching videos, there is no problem to face the university examination. Friends, till most of you have not submitted home assignments, please submit the home assignments to which we have to provide internal marks. Otherwise, it is difficult for us to give the marks. Definitely, even though you are appearing for the university exam, you will be failed. To avoid such situations, cooperate with us, submit the home assignments, come tests on mail ID or in the form of hard copy in the department earliest. Dear students, this is the last lecture as far as your syllabus is being considered. Hoping that next year at least we will come for face-to-face communication in the classroom. The time is the solution for that. Time is going to decide all those aspects. By wishing you all the best of luck for your university examination. Another fact is that as far as notes is being considered, notes are available at the Xerox Center. Try to collect it if you want. Otherwise, whatever the video lectures I have given, those lectures are sufficient to acquire much knowledge regarding the semiconducting device and also to solve the objective type questions in the university examination. Thank you all of you for cooperating me. As far as watching the video lectures are being considered. If you have got any doubts, any queries, any difficulties, any problems in solving the numerical examples, try to contact me on WhatsApp group or on mail ID, also on the telephone number provided to you. That's all about the syllabus of this particular academic year, semester 2. I hope you enjoyed these particular video lectures. In next year, we will again meet, expecting with face-to-face communication in the classroom, depending upon the time as one of the important factor. Take care of yourself, take care of your family members. Face the university exam, which is going to start from tomorrow. Most probably, you might be going to face the electronics paper number 3 and 4 on 20 and 21st August. So we are completing the syllabus today. That is 7th August. Till 15 days are there for your study purpose. Study well and face the exam. Hoping all the best for you. We'll stop here. We'll stop for this particular academic year. Stop for semester 2nd. Again, by wishing you best of luck for future and also for university examination. Let us stop today in all respects.